Hello students, today we will see the remaining portion of metals and nonmetals. In the last class, we talked about the physical properties of metals. So today we are going to study the chemical properties of metals. Okay, so we will start with chemical properties of metals. Okay. Chemical properties of metals. First, chemical properties means metals, reaction of metals with air or water or oxygen, then acids, etc. Okay. Now the first reaction we are studying is the reaction with air. Air means you can also say reaction with oxygen. Okay, this is the first reaction. And you know, different metals react differently with air or oxygen. Some metals will have more reaction towards air, whereas some metals will have less reaction with air. So according to it, we can see that which metal is more reactive and which metal is least reactive. Okay. So the reaction with air, generally I can say a metal, when it reacts with air or oxygen, it will form its corresponding metal oxide. You know, generally all the metals will react with oxygen to form the corresponding metal oxide. Okay. For example, we have studied this. Magnesium plus oxygen will give you magnesium oxide. Okay. Then next, copper plus oxygen will give you copper oxide. Okay. These two reactions we have studied earlier, the last chapter. Okay. Now, coming to metal oxides are normally basic in nature. Okay. So, what do you mean by this basic in nature? That means, normally, I will tell you with an example, magnesium plus oxygen will give you magnesium oxide. Do you remember in the first class, I have shown you the experiment where a magnesium ribbon is burned in a spirit lamp or a Bunsen burner. Now, what was the observation there? The observation was a white dazzling flame. Do you remember? A white dazzling flame. And what was the product? The product was magnesium oxide. And what was the color? Do you remember what is the color of the magnesium oxide? That was white ash. Isn't it? Now, you know this is a metal and the oxide is metallic oxide, that is magnesium oxide. Now, how will I say that this magnesium oxide or this metallic oxide is basic in nature? For that, we have to do one small activity. That means you take the magnesium oxide powder, okay, and dissolve it in water. Okay, what you did? You took some magnesium oxide and dissolve it in water, then you got a corresponding solution. Okay, that is magnesium hydroxide, that you will study later. In the second chapter, you have to study all this. Okay, just I am telling you how this comes, that's all. Okay, so the resulting solution, how I will check whether the resulting solution is acidic or basic. Okay, that is, there is one paper called as litmus paper. Okay, we will study in the second chapter. Just to understand this, I am telling now. Okay, there is a paper called as litmus paper. Two types of papers are there, that is, one is a blue litmus and the other is a red litmus. Okay, now, if a solution is basic in nature means, if we dip a red litmus paper into this, listen carefully, if I put a red litmus paper into the solution, if the red litmus paper is changing it into blue, then that solution is basic in nature. Correct? Acidic means the litmus paper, the blue litmus will changes into red. That is acidic. Red litmus changing to blue is basic in nature. That you will study later. Okay. So, what I mean to say is most of the metallic oxides are what? Basic in nature. Okay. Now, again if I write one more example of aluminium, aluminium plus oxygen will give you the corresponding oxide, aluminium oxide. Okay. If I balance it, 3, 2 and 4. Okay. Now, aluminium plus oxygen giving aluminium oxide. Now, when coming to aluminium oxide, then zinc oxide, etc. Some of the metal oxides, I already told you that these metal oxides are generally basic in nature, correct? But some oxides like aluminium oxide, Al2O3, then zinc oxide, etc. react with both acids as well as bases. See? Basic in nature means what? It reacts only with acids. Okay. But some oxides react with both acids as well as bases to form the corresponding salt and water. Okay. Now, that means this shows that some oxides or some metal oxides can react with both acids as well as bases to form the corresponding salt and water. Okay, actually this type of reaction you call it as a neutralization reaction. Okay, an acid plus a base will give salt plus water. But in this case, these oxides normally it react with acids to give salt and water. That because this act as base. Metallic oxides are basic in character. Do you understand? Metallic oxides are basic in character. That is why a base react with an acid to give salt and water. Actually that is happening. But in some cases it can react with both acids as well as bases to form the salt and water. And such a type of oxides are called as amphoteric oxides. What is it? It is called as amphoteric oxides. Now, what are amphoteric oxides? Amphoteric oxides are certain oxides like aluminium and zinc, that is their respective oxides, can react with both acid as well as bases to form their corresponding salt plus water. So, is it clear? Okay. I will write the equation for that. Okay. That is, you are taking example as an aluminium oxide, Al2O3. It react with acid, for example, HCl is an acid. What it will form? It will form the corresponding salt, that is AlCl3 plus water. Okay. If you balance it, you will have 2, 3 into 2, 6, then 2, so 2, Al2O3 and H2, 3, so it is 3H2O. See? This is a balanced chemical equation. So, here aluminium oxide, that is a metal oxide, react with the acid, isn't it, to form the salt, that is salt is aluminium chloride. Okay. At the same time, see, again this Al2O3 react with a base NaOH, react with the base to form the corresponding NaAlO2, that is the salt plus water. And this salt is called as sodium aluminate. Okay, sodium aluminate, NaAlO2. So, if you balance it, 2, then 2, hydrogen, 2 hydrogen. So, this is a equation. So, here what happens? Some metallic oxides like aluminium and zinc oxide react, they can react with both acid as well as a base to form the corresponding salt and water. And these type of oxides, you name it as amphoteric oxides. Correct? You got it? Amphoteric oxides. Okay. So, this is about the metallic oxides. Okay. Now, we will see what about something more about metallic oxides. You know, normally these metal oxides are insoluble in water. Normally insoluble in water. Okay. But Some metal oxides are soluble in water. Listen carefully. Some metal oxides, this is general case. Okay. Generally, metal oxides are insoluble in water, but some metal oxides are soluble in water. Now, such metal oxides react with water to form the corresponding hydroxides, or you call it as alkalis. That means, for example, sodium oxide, Na2O, you know the valency, oxygen 2, sodium 1, so cross multiply, you will get Na2O, 9th standard, plus water will give you the corresponding NaOH. So, this is very well soluble in water. Okay. Likewise, potassium oxide and water will give you KOH. See? So, this type of hydroxides, this is called as sodium hydroxide. We have studied in the 9th class. This is potassium hydroxide. So, these are soluble in water, and such oxides which are soluble in water are called as alkalis. Do you remember? In the last session, we talked about alkali metals such as lithium, sodium, potassium. Isn't it? Lithium, sodium and potassium can be cut with a knife. There I mentioned about the alkali metals. Why? Because now we understood what is the meaning of this alkali. Alkali means such metal oxides can react with water. Means it is readily soluble in water to form the corresponding hydroxide. So that is why they are called as alkalis. These are called as alkalis because it is soluble in water. So you understood this much. We have studied. Generally the metal react with oxygen to form metal oxide. Some examples are given, that is magnesium plus oxygen give you magnesium oxide. Then what we talked about, some metal oxides can react with both acids as well as bases to form the corresponding salt and water. And such oxides are called amphoteric oxides. Generally, metal oxides are basic in nature, isn't it? Likewise, non-metal oxides are what? Acidic in nature. So, what are amphoteric oxides? Those metal oxides which can react with both acid as well as bases to form the corresponding salt and water is called as amphoteric oxide. Example of amphoteric oxide is Al2O3, ZNO, zinc oxide, etc. So, you got that much clear? Okay. Now, having said this, now we will see which metal is more reactive and which metal is least reactive. So, when I talked about the reaction with air or oxygen, we have to see some points in your mind. That is, whether a metal is readily react with the air, that is oxygen, whether the reaction is fast or slow. Okay. Then you can see when we burn a metal, or a reaction means what? Burning with oxygen, correct? So, when burn with a metal with oxygen, is the flame, you can have a flame there, right? Is the flame is having some color? You should note that. Whether this flame is having a color, or what are the main products of this metal? Okay. So, then is that product soluble in water? So, keeping all these points in this reactivity, we can generalize the reactivity of certain metals with air or oxygen. That means, if a reaction is fast means what? The reaction is violent. That means, when the metal with oxygen, it will, the reaction is very, very fast. It takes place, the rate of the reaction is very fast. But some reaction, it is very, very slow. In some metal, there is a flame for the color. Okay. Now, the main product we can have, what is the main product with the air or reaction with oxygen? And is that oxide soluble in water or not? So, keeping all these points in the mind, we can have what? The reactivity of certain metals when it react with the air or oxygen. Correct? Now, have you remember the reactivity series or the activity series which we have learned in the last chapter? Okay, on recalling the reactivity series, I can say that if I put potassium and sodium, these two metals react violently with water. violently with air. What do you mean by violently? Violently means sudden reaction happens, and listen, as a result, when it is exposed to air, these two metals when exposed to air, it reacts violently with air, and what it happens, it burns in air. See, it burns in air. So can we keep this potassium and sodium simply in the in the surface? No, you can't keep sodium and potassium like that. So for that matter, you keep the sodium and potassium, we can immerse it in oils like kerosene oil. So we are keeping in the lab the potassium, we are having sodium in our lab. Okay, so we are keeping the sodium in kerosene oil. Why? Because it cuts off the air. If it comes in contact with the air, what happens? It will catch fire. That's it. That's the main point. It will catch fire. So I can show you the reaction once we were in the class. Okay, we will have that class, then I will show you. Okay, so what is the reactivity here? So we can say that sodium and potassium are highly reactive. Correct? Highly reactive. Why? Because it reacts violently in air and it catches fire. That is why we are keeping the sodium and potassium immersed in kerosene oil. Okay. Now coming back to, if you are remembering the reactivity series, then the rest of the metals like what? Like aluminium, then magnesium, then zinc, etc. Okay. Then calcium, etc. What happens to this is, these metals when react with oxygen or air, they form the corresponding metal oxides like aluminium oxide, then magnesium oxide, then zinc oxide or calcium oxide, correct? Now, the peculiarity of this oxide is, these metals react with the oxygen in the atmosphere, initially forming a protective layer of its oxide. Listen, these metals, it does not react violently. So what we will say? We will say it is moderately reactive, correct? It is moderately reactive. So these metals react with oxygen in the atmosphere, forming initially a protective layer of the corresponding oxide like aluminium oxide, zinc oxide, lead oxide, magnesium, etc. etc. Now, what is the peculiarity of this protective layer? Here I can mention this protective layer will prevent further oxidation. Do you get it? This prevents further oxidation. Now, if you recall the portion of corrosion in the last chapter, we said it is the effect of oxidation, right? Oxidation. The effect of oxidation we found in the daily life is, one is corrosion and second was the rancidity. Now, when we talked about corrosion, we said it is nothing but oxidation. There we talked about as the corrosion is harmful, isn't it? The corrosion is harmful. Why? A large amount of money is spent for corrosion, in like the corrosion of iron in bridges, etc. Isn't it? So there we talked about corrosion as a harmful effect, isn't it? But so many economic is, I have told you, right? The iron bridges are getting spoiled and so much economy is lost in that case. Therefore, we said that the corrosion is harmful. But the same thing I am telling here is, here the corrosion we say it as harmless. Why? Why? Because here this protective layer of this oxide, the initial layer of this oxide will prevent further from corrosion. That means if it gets corroded, I said the corrosion means eating up of that metal. It will get damaged or it won't be there after some time. Okay, it gets oxidized and it goes on like that. So here the corrosion is harmless. or the oxidation is harmless in nature. That is why we say that corrosion is both harmful as well as harmless. Okay, so here what happens, the metals like the moderately reactive metals like calcium, aluminum, magnesium, zinc, etc. will react with oxygen to form a protective layer of their oxide, which prevents from further oxidation. Clear? Okay. Now, so we can have that. Next comes iron. Now, if you burn iron in oxygen, what will happen? If you burn a block of iron, see, a block of iron, if you burn it, what will happen? Or if a reaction with air, what will happen? Actually, the reaction is very, very slow compared to these metals. Correct? So, we can say here there is a slow reaction of iron with the air or oxygen. Definitely it will form what? The corresponding oxide. Okay, Fe2O3. But if I take, instead of this iron block, if I take iron filings, what do you mean by iron filings? Iron filings means I have shown you, right, in the class, small iron filings, see, small iron filings. And I burn this iron filings, which I mean the reaction with oxygen, it will suddenly burn, or the reaction is more reactive when compared to an iron block. If I take iron block, the reaction is slow, but instead of iron block, if I take iron filings, the reaction is fast. Why so? Why? Because, see, if I take iron filings, what will happen to its surface area? In this iron block, the surface area is only this, okay. But for each iron filings, the surface area is more. So what happens? The reaction will become faster. So due to the increase in the surface area of iron filings, the reaction is faster. Just note it down, that's all. But normally in an iron block, the reaction is slow. Okay. Then if you take copper as an example, that is copper on reaction with oxide, it will form copper oxide. But remember, in the last chapter, when we studied about the oxidation, I have studied the case of copper. Do you remember? When the reddish brown copper is burned in a crucible or a china dish, what was the color of that copper oxide? I said a black coating is there. A black coating of copper oxide is there. That means the copper does not burn with flames, or it does not burn with flames. What happens? There is only a coating on the surface of the copper. That is a black coating on the surface of the copper. So when you compare the reactivity, now you can understand how the metals react in different way with air or oxygen. Sodium and potassium is vigorous reaction. Calcium, aluminum, magnesium, it is moderately reactive. Iron, the reaction is slow. Copper, even slow. And what about silver and gold? Silver and gold, you know, they are noble metals, right? They are noble metals. So there is no reaction with the oxygen. So comparing all this, you can say which is more reactive, potassium and sodium. Which is least reactive, silver and gold. Okay, so this is the reactivity series with what? With air or oxygen. Okay, now by only seeing the reactivity of oxygen, we cannot say that this element is more reactive or this element is less reactive. We have to go through so many reactions like reaction with water, reaction with acids, reaction with base, reaction with some other solutions, etc., etc. But today we saw the reaction with air or oxygen. Okay. Now, in this reaction with oxygen, I have to point out one more thing. That is, I talked about the certain low reactive or moderate reactive metals like magnesium, aluminum, zinc, etc. It reacts with oxygen to form an initial protective oxide layer of magnesium oxide or aluminum oxide or zinc oxide, right? Why this is useful? This is useful because these oxides prevents what? Further oxidation. This coating of this oxide layer prevents further oxidation. So, by a chemical method, we can have this protective layer of oxide, or we can make protective layer of oxides in a metal. And that reaction is called as anodizing. What is anodizing? Anodizing means making the element a thicker layer of oxides. First, at ordinary temperature, if you put an aluminium metal, it will have a small coating over the aluminium to form a protective coating. But if you want that aluminium oxide to be more and more thicker coating of an oxide layer, the chemical method which we used is called as anodizing. Okay, now just we will see what is anodizing. Anodizing means, as I said, it is making the metallic oxide a more thicker layer, or a thicker layer of oxide, that's all. Now, how you can make this anodizing? Suppose if we want to anodize aluminium, an aluminium particle, an aluminium some material of aluminium, if you want to make it anodizing, what you will do is, you take a clean aluminium metal, whatever be it, then what you should do is, you have to electrolyze it. Electrolyze it. You have studied electroplating etc. in the 8th standard, no? So, what anodizing means is, you take the aluminium particle at anode. Since the reaction takes place anode, that is called as, it is anodizing. So, you take the aluminium particle at the anode, right, and you electrolyze it with dilute sulfuric acid. If you electrolyze with dilute sulfuric acid, what will happen? Here, the oxygen is liberated at the anode. See, the oxygen, if you have this aluminium particle, the oxygen is liberated at anode, and this oxygen react with our aluminium particle, aluminium substance, to form what? Al2O3, the oxide layer. Now, as we pass on electricity, what happens? The electrolysis continues, and more oxide, thickening of that oxide layer in the surface of aluminium happens, correct? So, that is the process, you call it as anodizing. That is, at anode, you put the aluminium particle, then you electrolyze with the dilute acid. Here you put dilute sulfuric acid. Then what happens? Oxygen is liberated at that electrode. You know electrode, no? Anode and cathode. Okay. So, the oxygen gas is liberated at anode, which combines with the aluminium to form the layer. So, after anodizing, what happens? It will become thicker. See, the oxide layer. So, why this application? What is the application of anodizing? That means it protects or it prevents, that is a value point. See, it prevents further oxidation. It prevents further oxidation. So, that is why anodizing is important. Okay. So, I think that much all about the first reaction, that is reaction with the air and oxygen. As I told you, this is not the criteria. You have to see more reactions with the metals, and then only we can have the reactivity of metals. You know, different metals react differently with different substances. So, in this class, we talked about the reaction with air and oxygen. I hope you follow this. Okay, read the textbook thoroughly. Then after that, in next class, we will study the reaction with water. Okay, now you have got an idea, isn't it? Which metal is having reactivity more, that is, in this case, sodium and potassium. The sodium and potassium reacts violently with water, but at the same time, what happens to copper? It is less reactive. And what about silver? Silver and gold, being noble metals, they are non-reactive. So, now you got an idea of how the metals, different metals react with air or oxygen. Okay, so in next session, we will talk about the reaction, how these metals react with water. Okay, so till then, keep studying. Thank you, and make notes of your own. Okay.